So here's another system of equations, and I'm going to stick with kind of what I've been doing here. I'm going to take the top equation, mark it blue. I'm going to take the middle equation and mark that green. And the top equation, I'm going to multiply by -2. Now maybe you can see why I'm doing that. Well, I'm thinking I'll get a -2x and it'll cancel with a +2x. So it looks like I'm going to try to cancel out the x's. So that's my plan here. I'm going to write them over here, -2x minus 2y plus 2z equals 0. Okay, and now the green equation, I'm not going to do anything with it, I'm just going to write it down. 2x plus 4y minus 2z equals 6. Okay, so let me make sure I have that slided over a little bit. Make sure I have that all copied down right. Okay, so -2, -2y, +2z, 0, 2x, 4y, minus 2z equals 6. Okay, when I add those together, the x's are canceling out. I get 2y, and it looks like these z's are canceling out also, and I get 6, right? Okay. So I can solve for y, divide by 2, and I get y equals 3. Well, that's great. Now I know what y is. So now what do I want to do? Well, I can put in the y value. I could go back and eliminate the x's in the other equation. Let's go ahead and do that. Let's take our green equation, 2x, I'm going to copy it down, 2x plus 4y minus 2z equals 6. I don't think it's really going to matter in the long run, but anyway. And I'm going to make this bottom equation orange. So 3x plus 6y minus 3z equals 9. Okay, so we already know what y is, and you could plug the y value in. But like I said, I don't think it's going to matter for what we're going to do here. So let's say you just were like, okay, I'm going to get rid of x. All right, I'm going to multiply the top equation by a negative, I'll put a +3. And then the bottom equation by a -2. So I'm wanting to get a 6x and a -6x. Okay, so then the top one becomes 6x plus 12y minus 6z equals 18. So remember, you're distributing all of those in. So hopefully that looks good. I'm double checking my math. And then the bottom one, I'm getting -6x minus 12y plus 6z equals -18. So look at what happens here. The x's are canceling out, the y's are canceling out, the z's are canceling out. So you're getting 0, but it equals 0, right? So 18 and -18 is 0. So this is different than the last video, because in the last video we lost the variables, but it was a false statement. But this is a true statement. 0 does equal 0. So what does it mean? It means it's one of those cases where there are infinitely many solutions. And again, you can save yourself a little bit of work there. I kind of knew that that was going to happen because I looked ahead on this problem, but you don't always know that that's going to happen. So don't be surprised. Sometimes it happens where you lose your variables. And if you get a true statement, infinitely many solutions. If it's a false statement, then there's no solution. Okay, so now we've seen examples of those.